All right, I think this is pretty much everybody. The rest of them are normal people. I know that, so we're okay. All right, well, welcome everybody to the High Voltage Lab. This is where you will be learning about in the class this semester. A lot of what we're going to go over is going to be done in this room. I get to brag to you, you are standing in the largest high voltage lab in North America. We're the big dogs. Canada, Mexico, they can't touch us. And this lab, the big dog will bite you. I warn everybody about this lab. It's a fun lab, but beware. Now, in my lab, when we talk about high voltage, we're not talking about 100 volts or 1,000 volts or 50,000 or 100. This is for the kindergarten kids. I go 100,000 volts on the little blue and white box you see back there, step it up to 250,000 volts on that ring in the air, move that up to 1 million volts AC on this tower, 3 million volts of lightning sitting right there, 450,000 volts of DC behind me, 300,000 amps of current to the side. As they say, I've got the power. And with great power comes great responsibility, right? Who said that? Which universe are you from? Could have been Aunt May. Oh, you got to keep these things straight, man. You got to keep them straight. Well, my power or my responsibility with all this great power is very simple. We bring products in here and I blow it up. And I'm good at my job. We test everything under the sun in this lab. This morning we had 2 bucket trucks, 500 kV trucks. I used this to put 720,000 volts on them. They both survived. It's a miracle. Then we also have transformers. So you see a very tall transformer up there. That's tall and skinny. That's short and fat. I also got transformers over here. I got transformers in the background there. I got insulators on the side over there, insulators over here. I got cables in the background. If it deals with high voltage electricity, we test it. And a lot of times that means we take it to its limits. They want to know what can they withstand. And when you do that, things go bang. And in this building, you'll hear a lot of bangs and booms going on. It's me. So don't worry about it. Now, we do test things here that you do not traditionally consider electrical. And one of my pride and joys of that is this little piece right here. In 2018, Delta Airlines wanted to know what happens when lightning strikes their jets. So they actually cut apart a Delta 737. This is the tail end of a 737 jet. And we tested it. Now, a traditional lightning strike will give you anywhere from 5 to 15,000 amps of current in a strike. So we put 5,000 amps, 10,000 amps, 15,000 amps, and we chip the paint off. Is that exciting? No. I like excitement in my life. So instead of 5, 10, or 15,000 amps, I got rambunctious. And I put 160,000 amps, and I blew a hole in their jet. So that was 160,000. This one here is about 145,000. That one's about 57,000. I blow holes in jets. But I told Delta that I was not concerned with the fact that I can blow a hole in their jet. That don't bother me. You know what bothers me? My butt is sitting in this jet. I'm 30,000 feet in the air, and I realize that I got 2 pieces of fiberglass and some cardboard. That's all it is to the tail section of your jets. Think about that. Now, granted, this is the tail section. The wings, the body, and all, they're made out of aluminum. And we tested the aluminum. That aluminum's only about this thick. You're in a beer can with a cardboard tail sitting 30,000 feet in the air. And they asked me why I wear parachutes. But now here's what's neat. That's old school technology. Today, we're testing composite components. This is a carbon fiber composite that was developed at the Advanced Composite Institute out there. Where 160,000 amps, I blow a hole in it. 160,000 amps, I make a mark. Very rigid, very strong. So we test new materials. Now, in the electrical world, the big thing that we test for is insulators. This is a ceramic post insulator. They use these to support the power lines off the towers. Ceramic is good. This stuff will last 70 years. In fact, if you go to South Louisiana right now, ride down some of the old back roads, you're going to see little green insulators on old posts. It's been sitting there for 100 years. They're still sitting there. But ceramic does have a few issues. Now, one, this crap gets heavy. So this one here, about 35 pounds. That little gray one sitting right there, about 250 pounds. That brown one on that transformer, about 500 pounds. The bigger they get, the heavier they get. And you know what happens if you drop this on the ground? It shatters into 1,000 little pieces. And if you go to California and you put this up on a post and a big earthquake comes and it shakes it real hard, you know what happens? They snap off. Cantilever forces. So we need to do different than the ceramic. Today, we're testing polymers. This right here is the 35 kV suspension insulator. It is made out of silicon rubber. Fiberglass tube in the middle, silicon rubber sheds on the outside with metal ends. It's light, it's flexible, and if I drop it, it bounces. If I go to California and I put it up on a post, I can shake it till the cows come home and even go back. Nothing's going to happen. The stuff is very, very resilient. But what I don't know about this is how long is it going to last outside? What happens to rubber when you throw it outside? The sun bakes it. So we have to do aging tests in here. And for aging tests, I have my chambers. The first chamber you see with the door open, this is a salt fog chamber. And inside this chamber, I can generate a salt atmosphere like you get along the oceans, or you go up north where they spray salts on the roads in the wintertime. Makes everything corrode. In fact, you can look at the bottom of my chamber door there. You can see it's rusting. It's nasty. Second chamber you see over there is the ultraviolet radiation chamber. Now this one is pretty unique. I can do two types of radiation in it, UVA and UVB. If I put the UVA bulbs in that chamber, I can throw you inside that chamber, close the door, turn it on, and 10 minutes later you're going to walk out with a golden tan. It's a very big tanning bed. But if I put the UVB bulbs in that chamber and I throw you in that chamber, close the door, and turn it in, 10 minutes later your skin may start falling off. Now I do offer people the opportunity to get a tan. There's a 50-50 chance as to what's in there right now. Anybody want to risk it? Free tan or lose some skin. Either way, it's a win-win. Lose some weight or get a tan. All right. Behind that chamber, or actually behind that orange post that you see there, there's a little chamber, and that is my thermal chamber. And inside that chamber, I can generate temperatures from negative 75 degrees Celsius to 175. And then I have that big, tall orange tower there. This is my rain tower. I generate rainstorms in here, thunderstorms. And we use all of these to accelerate age this material. And what I'm finding today is that this will last about 25 years. So now the engineers go back and they get to come up with new methods to make it last better. But this is what we do. That is the main purpose of this lab, is to test products, everything that we do. You went through the electrical safety section on Wednesday last week. You understand what I talk about, the dangers of my lab. 35 thousandths of an amp can kill you. 25 volts is enough to generate that in the body. We got 1 million. Be very careful in the lab. That is the biggest thing I can tell you. Don't become comfortable. Pay attention. Watch out for others. That is the tower that I told you that put me down a couple of times. The impulse tower. It's a nasty piece of equipment, and it's trying to kill me. It's done twice. They say the third time's a charm, so I'm letting my students do all the work over there. I'm staying over here. They can fool with it. But this is what we're going to be using in the class this semester. We're going to talk about sources, AC source, DC source, Van der Graafs, current sources, impulse. These will be the lectures we're going to go through. So you go through the lecture, and then we're going to come down here and we're going to use it. Also in our course, we're going to talk about dielectric breakdown, breakdown in gases, breakdown in solids, breakdown in liquids. We're going to come in here. We're going to do breakdown mechanisms. So you're going to take what you learned theoretical, and we're going to put it in practical application here and see it in action. Then we'll also do experiments with partial discharge. We'll do experiments with lightning. So all of this is the 6, I think it's either 6 or 7 labs that we're going to come down here. You will get to come in. You're going to set it up. You're going to run the equipment. You're going to do it all. Then you'll take your data and write a report. So it's going to be fun. Like I said, this is a fun place. You can ask my students. Kelsey here has been with me for, what, 4 years now? Ever since freshman, working down here. It's a great place. We have a lot of fun in this lab. Do some unique things. Today you're going to see a lightning strike. We're going to strike that poor ship on the ground there. I used to do other demonstrations. You saw the little red army man in my picture. We blow him up. We blow up the fruits and all. Makes too big of a mess, so we don't do that anymore. But we do have fun. So today I want to do some little demonstrations. Let you see some of the lab in action and see what we do here. And then you'll sort of get an idea of what you're going to be doing when you come down here. So I always do my demonstrations small and work my way up big. My Van der Graaf generator is the first one. Now, do y'all know about the Van der Graafs? About it in the lab. We go through a section on it. Van der Graaf's been around since about 1929. Very simple machine. You have a sphere with a neoprene belt. This belt is going to rotate. I'll cut the machine on. It rotates the belt. There are a set of combs up in this top that strips away the electrons and sends them down here, making this a positively charged top. Now, the positive charged top discharges to a ground point here. Now, this one here, about 100,000 volts that we're doing. Now, it makes a little pop, pop, pop. That's not exciting. Like I said, I like excitement. So for the excitement, this is where I like to ask for a volunteer to step up. I see a lot of, all right, come on up. I like volunteers. Easy job for you. Step up on your platform right there. Now, take your right hand or left hand, your left hand. There you go. Put it right there on top of that sphere. Now, hold it there good and tight. We're going to cut it on. Now, we're going to start charging his body up to 100,000 volts. And we're going to give him a new hairstyle all at the same time. But now he's got the easy job. He gets to stand there and look pretty. I need volunteer number 2. Hey, I like these hands coming up. Step right on up here. I'm going to get you to step right here. Oh, no, no. Hold your elbow up. Hold your elbow up. And bring your elbow to his. Oh, yeah. And we send 100,000 volts to the next one. One more little person. Oh, no, you still stay here. You still stay here. Oh, yeah. I'm going to get you to stand next to him. Hold his hand. Ain't we friends? Now, elbow to elbow. So we pass it on. Okay, I can let you go. Love the hairstyle for the day. Any women want to come? Really long hair? Anybody? Anybody? Oh, yeah, scared.